Yo, down for the boss. So, good day, physicists. Welcome to today's session. Of course, we are going to be talking about the issue around mechanics. So, of course, before we can even talk about what exactly is mechanics, let us try to ask ourselves a question, which is what is physics? Because after all, we are interested in what is mechanics, which is, of course, a branch of physics. So I want us to understand that when we talk about physics, we are simply talking about the study of behavior of matter. We are interested in how matter behaves. That's just what we are doing then with physics, how matter behaves. So with the mechanics then, we are going to be looking at forces, giving credit to people such as Newton. So of course we're going to be learning about forces since we have recognized and realized that in actual fact these forces, they do what? They can cause an object to move somehow. And in actual fact that then is what mechanics is all about. Mechanics is just the study of motion of objects. So halala right now. So now of course for this motion to happen, there are some beautiful physical quantities that plays a critical role there. These physical quantities could include time. We know that everything happens within the vicinity of time. So in order for you to move from point A to point B, of course there should be some time taken. So that is why we say time is a very, very important physical quantity that we are going to talk of it about. It will help us also to be able to find speed, to be able to find velocity, to be able to find acceleration, all those things. Also, they are physical quantities. Of course, physical quantities of concern. Just what we are interested in for mechanics of Fanabor. So, halala right now. So now, as physicists who are to study mechanics, we must have the ability to do what? We must have the ability to identify physical quantities as either being scalars or vectors. You can't do mechanics without knowing what is a scalar. So you must know the difference then between the scalar quantities or the scalar physical quantities against the vector physical quantities. So now, magnitude, size, is a very, very important thing then in this regard. So it means when we talk about scalar quantities, we are just interested in those physical quantities that are only interested in the magnitude of a substance, on the magnitude of matter. So it means when we talk about scalar quantities then, by definition, we will say scalar quantities only includes magnitude. It's those physical quantities, of course, whereby we are only interested in the magnitude, such as mass, such as time. The mass is just 500 grams. I want 500 grams of sugar. You don't say you want 500 grams of sugar to the south of Clavotan. I want to tell for the boss. So of course, that is just what is happening here. Of course, you must have the ability to identify whether you are in scalar quantities or vector quantities. Then for the vector quantities, of course, we are talking about physical quantities as well. But these ones now, they include the magnitude. Not only the magnitude, but also the what? But also the direction. For instance, velocity. When I talk about velocity, I must give direction to say, well, I'm moving 60 kilometers to the west. There is a bit of direction to what I'm talking about. A very, very important physical quantity then, that one, velocity. Because velocity, if we understand velocity honestly, it will be as a result of understanding position. Because usually we say velocity is the rate of change of displacement, things like that. So you see, if you understand the velocity, it's like the center. Velocity will help you to be able to do what? It will help you to be able to know position. Velocity will also help you, of course, in being able to talk about what? To talk about acceleration, which is a very, very important physical quantity as well. Well, when we think of these physical quantities then, the physical quantities of concern, there are quite a few of them, of course, such as time, distance, Distance, it's a scalar. What else can we talk about? Speed, it's a scalar. Those are what we are interested in, of course, as physical quantities. But as for vector quantities, we'll be interested in things such as displacement, number one. After displacement, perhaps we will talk about velocity. Then after talking about velocity, of course, we'll advance our knowledge and talk about acceleration. So that's just what this session basically is all about. It's all about you having the ability to differentiate between the scalar quantities and the vector quantities. So, halala right now. My name is Mr. Mojakisane. Now, before we go to the examinations or to write any test for that matter, of course we must consult the physical sciences examination guidelines. They guide us as to what exactly is it that we must know before we go to that examination. So, hello right now. So before we can solve any questions, let us go through the examination guidelines and see what is it that they want us to know at least before we go to these examinations. So the first thing that they talk of and about under the introduction to vectors and scalars, they say that you must have the ability to list physical quantities. So that is what they say there. Remember that we've defined a physical quantity as being anything measurable. Time is measurable, mass is measurable, weight is measurable, force, charge, etc. All those are physical quantities. So we are more interested, of course, in determining whether those physical quantities are scalar quantities or they are vector quantities. So halala right now. So that is the first bullet point there. Then the second one says that you cannot go to the physical sciences examination in any way, howsoever. You just can't without having the ability to define a vector and a scalar quantity. So question 2.1 will be like, define a vector, define a scalar. Free 2 marks. That's it. So we must of course have the ability to define a vector then as a physical quantity with both magnitude and direction. That is key. To say, well, when we are talking about these vector quantities, of course they include both the magnitude and direction. Whereas, of course, for a scalar is simply a physical quantity with magnitude only. Remember, by magnitude, we talk about size only. Well, time is 12 o'clock. You can't say 12 o'clock to the south. You just can't. So the second learning objective says that we must have the ability, of course, to define a vector and a scalar quantity. Now, the third bullet point, therefore, says that you cannot go to the physical sciences examination without having the ability to represent vectors graphically with an arrow. Whereby, of course, we are aware that the length of the arrow represents the magnitude, the size, and the arrowhead represents the direction of the vector. So that is very, very important. So the graphical representation of vectors, you must have the ability to do that. Because in actual fact, for you to do mechanics grade 11 and also mechanics grade 12, of course, you must have the ability to understand the graphical representations of vectors. They say then, use the force vector as an example to show equality of vectors, negative vectors, and addition of vectors in one dimension only. Now remember that when we talk about one dimension, we are talking about motion in a straight line. Motion along a straight line. It's either you are going back and forth or whatever, but it's motion in a straight line. But what about the concept of equality of vectors? Well, when we talk about equality of vectors in Fanaboso, we say, well, this is a situation whereby we're having two or more vectors, of course, having the same magnitude, also having the same direction, then that way we can talk about equality of vectors, because the Holy Bible of physical sciences, the examination or guidelines says that we must know what is equality of vectors, negative vectors, and addition of vectors. Now, the other thing that you must make sure that you are able to do as free to marks is, of course, to have the ability to define a resultant. So a resultant vector, because question 2.1 perhaps or 3.1 might ask you a question to say, define the term resultant vector. Right now, this is free to marks. So define a resultant as a single vector having the same effect as two or more vectors together. That is, of course, the definition of the concept resultant vector. Now, last but not least, of course, in the bullet points there under vectors and scalars is, of course, to have the ability to determine a resultant graphically using the tail-to-head method, a very important method, that one, the tail-to-head method. Of course, have the ability to determine or give the resultant graphically. So you must also have the ability, of course, to give the resultant, of course, by calculation as well. You are a physicist, so of course, this is for a maximum of four force vectors in one dimension, which is, of course, along a straight line. Those are the learning objectives. The examination guidelines are guiding you to say this is all you need to know, of course, about vectors and scalars as part of paper 1 physics. So now let us, of course, go and see what type of questions they can ask. Right now, the simple activity here, number 1 to 3. So for number 1, they say, in your own words, explain the difference between a scalar and a vector. Then for number 2, they say, list 2 scalars and 2 vectors that are commonly used in statics. Last but not least, determine whether the following quantities are scalars or vectors. They say 30 kilograms, 4 meters, 30 newtons down, 60 seconds, a force of 80 pounds applied at 45 degrees. Now, those are some of the things that they can ask, of course, in a test or in an exam. So what I want you to do at this time,